Hello and welcome. Tonight, we'll be exploring one of humanity's greatest dreams and one of its greatest challenges, the planet Mars. For generations, Mars has captured our imagination. It has appeared in ancient myths, inspired science fiction, and become the destination of some of the most ambitious engineering projects ever attempted. To many people, it represents hope, curiosity, and the possibility that humanity might one day take its first steps toward becoming a truly spacefaring civilization. Yet behind that dream lies a quieter, more difficult question. Reaching Mars may one day become routine. Surviving there is something entirely different. Every breath, every sip of water, every warm room, and every small light glowing inside a habitat would exist only because countless machines continue working without pause. Unlike Earth, Mars offers almost none of the comforts that life quietly depends upon every single day. As we gently explore this remarkable world tonight, we'll discover that the story of Mars is not only about rockets or astronauts. It is also a story about planets that change over billions of years, about fragile environments, and about what it truly means for a place to support life. Along the way, we may even come to appreciate our own world a little more deeply, simply by imagining what life is like without the things we usually take for granted. So, find a comfortable place to rest. Allow your thoughts to slow like evening shadows stretching across a quiet landscape, and let's gently begin our journey into one of the most fascinating questions in modern science. When most people picture Mars, they imagine an endless desert painted in shades of rusty red. A lonely horizon stretches beneath a pale sky, interrupted only by scattered rocks and distant mountains. It is a place so silent that even the wind seems to whisper rather than roar. At first glance, it feels like a world that has always been empty, always been cold, and always been lifeless. But appearances can be wonderfully deceptive. If you could somehow travel backward through time, not by years or centuries, but by billions of years, you might hardly recognize the same planet. Imagine standing on ancient Mars long before humanity, before dinosaurs, before even the earliest forests appeared on Earth. Instead of endless dust, you might hear the gentle sound of flowing water. Rivers would carve winding paths across broad valleys. Lakes would gather beneath towering cliffs. Some scientists even believe that a vast ocean may once have covered much of the planet's northern hemisphere, reflecting sunlight beneath a thicker sky. It is a remarkable thought. The dry channels that spacecraft photograph today may once have carried rushing water for thousands or even millions of years. Places that now seem frozen in time may once have been surprisingly dynamic, shaped by rainfall, melting ice, and flowing streams. One of the strongest clues comes from places like Jezero Crater, where NASA's Perseverance rover continues its exploration today. Long before it became an empty basin filled with dust, this crater appears to have hosted an ancient lake. Even more intriguing, scientists have identified the unmistakable shape of a river delta, a fan-shaped deposit of sediment left behind where a river slowly emptied into standing water. Here on Earth, river deltas are often among the richest environments for preserving traces of ancient life. Layer after layer of mud gently settles over countless years, quietly protecting whatever becomes buried beneath it. It is one of the reasons scientists are so interested in these Martian landscapes. If microscopic life ever existed on Mars, even for a relatively brief period, places like these may still preserve tiny clues waiting patiently beneath the dust. It is rather like opening an old family photo album. The people inside those photographs may no longer be present, but the images tell us they were once there. Mars offers something similar. Its valleys, mineral deposits, and ancient shorelines are like faded photographs of a world that looked very different from the one we see today. Of course, this raises an even more fascinating question. If Mars once possessed rivers, lakes, and perhaps even an ocean, what happened? The answer was not a sudden catastrophe. There was no single dramatic moment when the planet changed overnight. Instead, the transformation unfolded so slowly that no observer could ever have watched it happen. It was a story measured not in lifetimes, but in hundreds of millions of years. Deep inside young Mars, molten rock once churned much like soup gently simmering inside a pot. That movement helped generate an invisible magnetic shield surrounding the planet. Although you could never see it with your eyes, this magnetic field played an extraordinary role. It quietly deflected much of the charged particles streaming outward from the sun, acting like a protective umbrella wrapped around the entire world. Earth still possesses such a shield today. Every moment, without us noticing, it helps protect our atmosphere from the constant flow of energetic particles arriving from space. It is one of those invisible gifts that makes our planet feel wonderfully ordinary. Mars, however, slowly lost this protection. As its interior cooled over immense spans of time, the processes generating its magnetic shield gradually weakened. Eventually, the shield disappeared almost entirely. Without that invisible guardian, the thin upper layers of the Martian atmosphere became exposed to the relentless stream of particles flowing from the sun. Little by little, year after year, century after century, and then over billions of years, the atmosphere slowly drifted away into space. You might imagine it like leaving a warm cup of tea outside on a cold morning. At first, the steam rising from the surface is almost impossible to notice. Yet, if you return much later, much of the warmth has quietly vanished. Nothing dramatic happened. There was no sudden explosion of steam. The warmth simply escaped, one tiny breath at a time. Mars experienced something surprisingly similar. Its atmosphere did not disappear in a single event. It slowly leaked away until it became only a faint remnant of what it once had been. As the atmosphere grew thinner, it could no longer hold heat as effectively. Temperatures fell. Liquid water became increasingly unstable. Rivers dried. Lakes disappeared. Any remaining water gradually froze beneath the surface or escaped into space. The once active planet slowly settled into the cold, quiet landscape we recognize today. When we call Mars a dead planet, we do not mean that it is uninteresting or completely empty. We mean that the natural conditions capable of supporting human life have almost entirely vanished. The world before us is not merely distant. It is a place that lost many of the qualities that once made it more welcoming than it appears today. And perhaps that is what makes Mars so captivating. It is not simply a barren desert. It is the story of a planet that changed, a reminder that even worlds can have histories, and that beneath every layer of red dust lies the memory of a very different past, one that quietly invites us to ask why humanity still dreams of returning life to a world that seems to have forgotten what living once felt like. There is something quietly fascinating about the way Mars has changed in our imagination. For much of human history, it was little more than a reddish point of light drifting slowly across the night sky. Ancient civilizations gave it names inspired by fire, war, or mystery, simply because its unusual color made it stand apart from every other wandering star. It remained a distant object of curiosity for thousands of years, unreachable except through stories and imagination. Today, however, Mars has become something entirely different. It is no longer simply a bright dot above us. It has become a destination. That simple change, from something we observe to somewhere we hope to visit, raises a surprisingly difficult question. If Mars is so cold, so dry, and so incredibly hostile, why do we keep returning our attention to it? Why invest decades of research, extraordinary engineering, and enormous resources into reaching a place where humans cannot even take a single breath without the help of technology? Part of the answer lies in curiosity, perhaps one of the oldest qualities our species possesses. Long before telescopes existed, people crossed oceans simply because they wanted to know what lay beyond the horizon. Climbers stood beneath towering mountains and wondered what the world looked like from the summit. Explorers entered dense forests and vast deserts, not because survival required it, but because curiosity gently pulled them forward. Mars represents another horizon. Only this time, the horizon lies millions of kilometers away. Scientists are especially interested in one question that has quietly lingered for generations. Was Mars ever alive? Not with forests, birds, or great animals roaming across its surface, but perhaps with something far smaller, tiny microorganisms living quietly beneath shallow lakes or hidden within warm underground water would already transform our understanding of life in the universe. Even the discovery of a single ancient microbial fossil would answer a question humanity has carried for centuries. Did life begin only once, or can the universe create living worlds more than once? That possibility makes every layer of Martian rock feel almost like a page from an unimaginably old history book. Every rover exploring the surface is, in its own quiet way, turning those pages one by one. Mars also offers another remarkable opportunity. Sometimes, the best way to understand your own home is to leave it for a while. Imagine spending your entire life inside one house. Every room feels ordinary because you have always known it. Then one day, you visit another house built in a completely different way. Suddenly, details about your own home become much easier to notice. Planets work in much the same way. By studying Mars, scientists better understand Earth. Why does Earth still have flowing oceans while Mars does not? Why did one planet remain warm enough for life, while the other slowly became frozen and dry? How important is our atmosphere? How important is our magnetic field? Questions about Mars often become questions about ourselves. In a quiet sense, Mars allows us to appreciate Earth by showing us what Earth might have become under different circumstances. There is another idea that occasionally appears in discussions about Mars, one that is both practical and philosophical. Some people describe Mars as a kind of backup, not because anyone wishes to abandon Earth, but because placing all of humanity in a single location has always carried risks. Throughout history, civilizations have faced volcanic eruptions, pandemics, asteroid impacts, climate shifts, and countless other unexpected challenges. None of these possibilities means Earth is doomed. Rather, they remind us that spreading knowledge and people across more than one world could make civilization more resilient over very long periods of time. Whether that vision eventually becomes reality remains uncertain, but it continues to inspire scientists and engineers to think beyond the limits of a single planet. Of course, dreaming about Mars is one thing. Actually getting there is something entirely different. Although Mars sometimes appears close in the night sky, space is astonishingly large. The distance between Earth and Mars is constantly changing because both planets move around the Sun at different speeds. Some years they drift relatively close together. At other times they find themselves on opposite sides of the solar system. This means spacecraft cannot simply leave whenever they wish. Instead, mission planners patiently wait for special launch opportunities when both planets happen to be positioned in a way that allows the journey to require less fuel. These opportunities arrive only once every couple of years, making every mission the result of careful timing rather than simple determination. Even under the best conditions, the voyage itself is remarkably slow. A spacecraft carrying people would spend somewhere between 6 and 8 months crossing the enormous distance between the two planets. There are no landscapes passing beneath the windows, no airports, no emergency landing sites, no roadside assistance waiting just beyond the next horizon, only darkness, stars, and the quiet hum of life support systems working every second. Life aboard such a spacecraft would probably resemble living inside a very small home that never stops moving. The same walls, the same companions, the same routines, day after day. Week after week, month after month, eventually, Earth itself would begin to shrink. At first, our planet would still appear large enough to recognize its familiar blue color, but as the months passed, it would slowly become smaller and smaller until it resembled little more than a bright point of light among countless other stars. It is difficult to imagine how that sight might feel. For the first time in human history, home would no longer look like a world. It would look like a memory. Communication would become equally strange. Here on Earth, we have grown accustomed to conversations happening almost instantly. Video calls connect families separated by oceans. Messages travel around the globe in moments so brief that we rarely think about them. Mars changes that experience completely. Signals traveling at the speed of light still require many minutes to cross the enormous distance between the two planets. A simple question cannot receive an immediate answer. Even the most ordinary conversation becomes an exchange separated by long periods of waiting. Imagine telling someone that a machine has stopped working. You would not hear an answer right away. Instead, silence. Only after many long minutes would advice begin its journey back toward you. This means that the people living on Mars could never depend upon constant guidance from Earth. They would have to become explorers in the truest sense of the word, not because they are alone, but because help is always far away. This changes the meaning of responsibility. Every decision matters a little more. Every repair matters a little more. Every carefully planned routine becomes part of survival itself. By the time the first human footsteps finally press gently into the reddish soil of Mars, the greatest achievement will not simply be crossing millions of kilometers through space. It will be arriving as a small group of people who have already learned that exploring another world begins long before the destination appears through the spacecraft window, and that the greatest distance they have crossed is not measured only in kilometers, but in the quiet realization that they are farther from home than any human beings have ever been before. By the time the first explorers finally arrive on Mars, they will already have accomplished something extraordinary. They will have crossed millions of kilometers through empty space, watched Earth slowly disappear into the darkness, and spent months living inside a spacecraft no larger than a modest home. Yet, as remarkable as that journey may be, stepping onto the Martian surface will not signal the end of their greatest challenge. In many ways, it will simply mark the beginning. When people imagine a future settlement on Mars, they often picture advanced technology. Giant rockets rise into the sky. Powerful machines construct habitats. Sophisticated computers monitor every system. Everything appears futuristic, precise, and almost effortless. Reality is likely to feel much quieter. Life on Mars may resemble less a spectacular science fiction adventure and more an ordinary daily routine carried out under extraordinary conditions. Every morning begins inside the same small habitat. The same narrow corridors, the same familiar faces, the same carefully controlled air. Outside the walls stretches an endless landscape where no one can simply go for a walk. On Earth, when you feel overwhelmed, you might step outside, breathe fresh air, visit a nearby park, or simply take a drive with no particular destination. These small freedoms are so familiar that we rarely notice them. Mars quietly removes almost all of them. The air outside cannot be breathed. The temperature outside can quickly become dangerous. Even opening a door requires careful preparation. Stepping outdoors is no longer a casual decision. It becomes an operation. Every excursion demands protective clothing, equipment checks, communication systems, oxygen supplies, and careful planning. Something as ordinary as inspecting a solar panel or collecting a rock sample may require hours of preparation before a single foot touches the dusty ground. Afterward, the astronauts return inside. The door closes, air pressure slowly returns, helmets come off, and life continues within the same carefully protected environment, day after day, month after month, perhaps even year after year. It is not difficult to imagine how such a routine could slowly reshape the human mind. Scientists already study environments that resemble this kind of isolation, even here on Earth. Research stations in Antarctica remain surrounded by ice for many months each year. Crews aboard submarines spend long periods beneath the ocean without seeing sunlight. Small teams live together in confined spaces, following structured routines while separated from family and familiar surroundings. Again and again, these studies reveal an important lesson. The greatest challenge is often not physical exhaustion, it is psychological endurance. Human beings are remarkably social creatures. Even those who enjoy solitude usually know that they can leave whenever they wish. A quiet afternoon at home feels different when the front door remains unlocked. Mars offers no such comfort. There is no afternoon walk through a nearby neighborhood, no unexpected visit from friends, no weekend trip to another city. The habitat becomes an entire world. Imagine reading the same favorite book every evening for months. At first, its familiar pages may feel comforting. Eventually, however, you begin noticing every sentence because there is nothing new to discover. Life inside a Martian habitat could feel surprisingly similar. The same dining table, the same sleeping quarters, the same exercise equipment, the same view through carefully reinforced windows. Even the beautiful reddish landscape outside might gradually become as familiar as the wallpaper inside your own home. That is why selecting a crew for Mars involves far more than finding brilliant scientists or highly skilled engineers. A successful explorer must also be someone who remains calm when plans change unexpectedly. Someone who can solve problems without panic. Someone who can disagree respectfully with others while continuing to work together. In such an isolated environment, patience becomes just as valuable as technical knowledge. A misunderstanding that might seem trivial on Earth could slowly grow into something much larger when there is no opportunity to simply spend time apart. Trust becomes one of the colony's most precious resources, not because trust repairs machines, but because trust helps people repair problems together. This is one reason future crews will probably spend years training with one another long before they ever leave Earth. They will learn each other's habits, strengths, weaknesses, and ways of thinking. They will practice solving emergencies together until cooperation becomes almost instinctive. A successful mission depends not only on advanced technology, it depends upon relationships. As we begin to imagine daily life more clearly, another realization quietly appears. The habitat itself is not really a house. It only resembles one. In reality, it behaves much more like a tiny spacecraft that never stopped flying. Every breath taken inside must be carefully managed. The air cannot simply drift away through an open window because there are no open windows. Instead, machines constantly circulate and clean the atmosphere inside. Carbon dioxide must be removed. Fresh oxygen must be supplied. Temperature must remain comfortable despite the bitter cold waiting just beyond the walls. Water follows a similar story. On Earth, turning on a faucet feels wonderfully ordinary. Few people pause to wonder where that water came from or where it goes afterward. On Mars, every single drop becomes valuable. Water is collected, filtered, cleaned, used again, and then cleaned once more. Rather than treating water as something abundant, future settlers may think of it the way sailors once thought about fresh drinking water during long voyages across the ocean. Carefully measured, carefully protected, never wasted. Food, clothing, medical supplies, replacement parts, scientific equipment, and even the smallest tools all share something in common. None of them can be purchased from a nearby store. If a simple valve breaks, someone cannot drive across town to buy another one. If a specialized filter fails, there is no delivery truck arriving tomorrow morning. The colony must either repair what it already has or learn to build a replacement itself. Little by little, an important truth begins to emerge. Living on Mars is not about creating luxury, it is about creating reliability. Every machine should be simple enough to repair. Every important system should have a backup. And wherever possible, that backup should have. Engineers sometimes describe this philosophy using technical language, but the underlying idea is beautifully simple. When something is essential for survival, you never want only one way for it to work. Imagine carrying a flashlight during a long hike through a dark forest. You would probably bring extra batteries, perhaps even a second flashlight. Not because you expect failure, but because darkness is not the best time to discover that your only light has disappeared. A Martian settlement follows exactly the same principle. Air systems need backups, water systems need backups, power systems need backups. Even individual sections of the habitat are likely to be designed so they can be sealed off if damage occurs, allowing the rest of the colony to continue functioning safely. The result may not look like the shining futuristic cities often imagined in films. Instead, the first settlement will probably resemble something much humbler. A few carefully protected modules connected together, then another module, then another, growing slowly, patiently, almost like a small village appearing one building at a time in the middle of an enormous desert. Perhaps that quiet image captures the future of Mars better than any dramatic vision ever could. Not a sudden city rising overnight beneath a crimson sky, but a handful of determined people learning, day by day, how to build a place where life can continue just a little longer than it could the day before. And once that fragile shelter finally exists, another question begins to emerge just beyond its walls. Even the safest home cannot protect its inhabitants forever if the world outside continues to expose them to dangers that no walls can completely keep away. If the first Martian settlers eventually build warm, comfortable habitats, there may come a day when life begins to feel surprisingly ordinary. Someone prepares breakfast while another checks scientific instruments. Plants quietly grow beneath gentle lights. Conversations drift through narrow hallways. A kettle warms water for tea. Outside, the sun slowly rises over a landscape of red dust, just as it has for billions of years. From inside, it might almost feel like home. Yet beyond those carefully built walls, Mars continues to remind its visitors that appearances can be misleading. Many of the greatest dangers on the red planet are completely invisible. You cannot hear them, you cannot smell them, you cannot watch them approaching across the horizon. And perhaps that makes them even more unsettling. One of those invisible dangers comes from space itself. Our universe is far from empty. Between the stars travel countless tiny particles carrying enormous amounts of energy. Some are released during powerful eruptions from the sun. Others have spent millions of years racing across our galaxy after being launched by exploding stars far beyond our own solar system. On Earth, we rarely think about these invisible travelers, not because they do not exist, but because our planet quietly protects us. High above our heads, Earth's atmosphere acts like a thick blanket, absorbing much of the incoming radiation before it ever reaches the ground. Surrounding that atmosphere is an invisible magnetic shield that gently guides many charged particles away from the planet altogether. Every day of our lives, these natural defenses work silently without asking for recognition. Mars is different. Long ago, as we discovered earlier, its protective magnetic shield disappeared. Its atmosphere gradually became much thinner. Together, those two changes left the surface far more exposed than the world we call home. Imagine standing beneath a sturdy roof during a heavy rainstorm. Most of the rain never reaches you. Now imagine removing both the roof and the walls. The rain itself has not changed, only your protection has. That image captures something important about Mars. The universe surrounding the planet is not uniquely dangerous. Rather, Mars has lost much of the protection that Earth still enjoys. Radiation is often imagined as something dramatic, almost like a bolt of lightning or a burst of brilliant light. In reality, much of it is far quieter. A useful way to picture it is to imagine an endless stream of tiny grains of sand carried by a strong wind. One grain striking a window causes little concern. Even a handful leaves almost no visible mark. But imagine that same window standing in the storm day after day, year after year. Eventually, the glass begins to change. Radiation affects living cells in a somewhat similar way. Its greatest danger is usually not immediate injury. Instead, it quietly increases the chance that small damage may accumulate over many years. Scientists pay close attention to this gradual process because human cells are constantly repairing themselves. Most of the time, those repairs happen remarkably well. Yet no repair system is perfect forever. The longer someone remains exposed, the more opportunities exist for tiny mistakes to accumulate. That is why future missions to Mars must think not only about arriving safely, but about limiting exposure throughout the entire journey. The voyage through deep space already lasts many months. Then comes the stay on Mars itself. By the time astronauts finally return home, they may have spent years outside Earth's natural protective shield. This is one reason engineers devote enormous effort to designing safe places where astronauts can spend most of their time. The goal is not to eliminate radiation completely. With today's technology, that is nearly impossible. Instead, the goal is to reduce it as much as reasonably possible. Interestingly, one of the most useful protective materials is something wonderfully familiar: water. We usually think of water simply as something we drink, cook with, or use for washing. But water also helps absorb certain forms of radiation surprisingly well. That means tanks storing water may serve more than one purpose inside a Martian habitat. Besides supplying daily life, they can also become part of the habitat's protective design. The same idea applies to the Martian soil itself. Rather than leaving habitats fully exposed on the surface, many scientists suggest covering them with thick layers of local soil or building them partly underground. Others have proposed using enormous ancient lava tunnels formed billions of years ago when Mars was still volcanically active. These tunnels are fascinating places to imagine. Long ago, rivers of molten rock flowed beneath their ceilings. When the flowing lava eventually drained away, enormous hollow passages remained behind, stretching beneath the surface like natural caves. Today, those ancient tunnels may offer something remarkably valuable: protection. Instead of building an entire shield from scratch, future settlers might simply allow the planet itself to provide one. It is a beautiful example of working with nature instead of constantly fighting against it. Radiation, however, is only one invisible challenge waiting outside. Another comes from something much closer to the ground: dust. At first glance, Martian dust hardly seems frightening. It looks soft, almost powdery, perhaps even beautiful when sunlight catches it drifting gently across the landscape. Yet appearances can once again be deceptive. Imagine the fine flour floating through a kitchen while someone bakes fresh bread. Now imagine each grain being much sharper, much drier, and capable of finding its way into almost every tiny opening. Martian dust is extraordinarily fine. It clings stubbornly to equipment. It settles into mechanical joints. It coats windows. It slowly reduces the efficiency of solar panels. Given enough time, even carefully designed machinery may begin wearing down under its constant presence. For astronauts, the challenge extends beyond machines. Whenever they return from working outside, every suit, every boot, and every tool must be cleaned carefully before entering the living space. Tiny particles carried indoors could gradually become an unwanted companion inside the habitat itself. Keeping dust outside may become one of the colony's daily routines, repeated so often that it eventually feels as natural as wiping mud from your shoes before entering your own home. There is another quiet challenge that future explorers will experience every hour of every day: gravity. Here on Earth, gravity feels so familiar that we almost forget it exists. Every step, every jump, every object resting on a table, everything quietly obeys the same invisible force. Mars offers only about 1/3 of Earth's gravity. At first, this might sound rather pleasant. Walking could feel lighter. Carrying equipment might become easier. A playful leap might send someone floating farther than expected. Children often dream about such possibilities, but the human body evolved under Earth's stronger pull. Bones constantly renew themselves because gravity gently asks them to remain strong. Muscles stay healthy because every movement requires effort. Even the heart has spent an entire lifetime learning how to circulate blood under Earth's familiar conditions. Change gravity, and the body gradually begins adapting. Scientists already know that spending long periods in space can weaken muscles and reduce bone strength. Mars may lessen those effects compared with complete weightlessness. Yet no one knows exactly what happens after decades, or even generations, living beneath its gentler pull. Could children born there grow differently? How might aging change? Would future generations feel equally at home on both worlds? These are questions science has not yet answered. Perhaps that uncertainty is one of the most humbling parts of the entire journey. For all our remarkable technology, there are still chapters of this story that no one has written. Mars remains not only a destination, but also a teacher, quietly reminding us that every new world carries lessons we cannot fully learn until we arrive. If you were to arrive on Mars tomorrow, carrying only the clothes you wore and the supplies inside your spacecraft, you would quickly discover a simple truth. Mars is not waiting for us. There are no houses standing quietly beneath the pale sky, no roads winding across the landscape, no power stations humming in the distance, no farms, hospitals, workshops, or warm shelters where tired travelers can spend the night. Everything that makes a place feel livable must first be created. In many ways, the greatest engineering challenge of Mars is not transportation, it is construction. Building a settlement on another planet sounds almost impossible at first. Yet when engineers think about the problem, they often begin with a surprisingly ordinary question: who should arrive first? Our first instinct might be to answer, people. After all, people are builders. We solve unexpected problems, adapt to changing conditions, and make decisions that machines still struggle to understand. But Mars quietly changes that logic. Every extra person requires more food, more water, more oxygen, more living space, more protection. Simply keeping one human being alive for months requires an astonishing amount of equipment. Because of that, many scientists imagine a different beginning. Long before the first astronauts step onto the surface, robots may already be hard at work. Picture a quiet Martian morning. The wind drifts gently across an empty plain. There are no voices, no footprints, and no lights glowing beneath the sky. Only a handful of robotic machines move slowly across the landscape, carrying tools instead of passengers. Some level the ground, others unload equipment. A few carefully assemble power systems or communication antennas. Another may begin preparing the foundation for the first human habitat. There is something almost poetic about the idea. The first builders on another world may not breathe at all. Unlike humans, robots never become lonely. They never need warm meals. They never complain about repetitive work or long hours. They simply continue performing one task after another with remarkable patience. Of course, they are not perfect. Machines can break. Dust can interfere with moving parts. Unexpected terrain can create problems no computer fully anticipated. Yet every hour of work completed before humans arrive makes the settlement a little safer. Instead of landing on an untouched world, Astronauts would arrive at a place already beginning to resemble a home. Once construction begins, another practical question appears. What should we build with? On Earth, constructing a house usually means transporting bricks, steel, concrete, glass, wood, and countless other materials to the building site. That approach works because construction stores are never very far away. Mars offers no such convenience. Every kilogram launched from Earth requires enormous amounts of energy and careful planning. Sending thousands of tons of building materials across space would be extraordinarily expensive and painfully slow. So engineers have begun thinking differently. Rather than bringing an entire city from Earth, perhaps humanity should learn to build with what Mars already provides. The reddish dust covering the planet may not seem especially useful at first glance. It clings to boots. It blows across empty plains. It settles quietly over rocks that have remained untouched for millions of years. Yet hidden within that dusty surface lies the raw material for future buildings. Imagine making sand castles on a beach. Individual grains of sand slip easily through your fingers. Alone, they seem almost useless. But when those grains are carefully packed together, they suddenly become strong enough to hold shape. Researchers hope something similar may eventually be possible on Mars. Robotic construction systems could gather local soil, process it, and slowly build protective walls layer by layer. Rather than carrying every brick across space, settlers would simply reshape the planet beneath their feet. It is a wonderfully practical idea. Instead of asking Mars to become Earth, we begin learning how to work with the materials Mars already offers. Another possibility feels almost the opposite. Instead of building heavy structures immediately, engineers could transport lightweight habitats folded tightly inside rockets. After landing, these structures would gradually expand, rather like carefully unfolding a camping tent. Of course, the comparison is only partial. A Martian habitat would be far stronger and far more sophisticated than any tent used on Earth. Its walls would contain multiple protective layers, designed to keep air inside while shielding its occupants from the harsh environment outside. Even so, the basic idea remains surprisingly familiar. Carry something compact, expand it after arrival, then strengthen it using local materials. A third possibility takes an even quieter approach. Rather than constructing everything on the surface, perhaps the safest home has already existed for billions of years. Earlier, we imagined enormous tunnels left behind by ancient rivers of molten rock. These underground passages may stretch for remarkable distances beneath the Martian landscape, protected by thick layers of stone above. Living inside such a place might feel rather unusual. Instead of waking to broad views across the horizon, settlers could begin each day beneath ceilings shaped by volcanic activity long before complex life appeared on Earth. Yet those ancient chambers offer something precious: stability. Temperatures change less dramatically underground. Radiation is reduced. Dust storms become far less troublesome. Nature itself has already completed part of the engineering. Regardless of which design eventually proves most successful, every habitat must solve the same basic problem. It must create a tiny piece of Earth inside a world that is nothing like Earth. The air pressure must remain comfortable. The temperature must stay warm despite the bitter cold outside. Fresh air must continuously circulate. Moisture must be carefully controlled so equipment continues functioning properly and people remain healthy. Even something as ordinary as opening a door becomes surprisingly complicated. On Earth, opening your front door simply connects one comfortable environment to another. On Mars, a door separates two completely different worlds. Before anyone can leave the habitat, special rooms allow the pressure to change gradually. Equipment is checked carefully. Dust is removed when explorers return. Every movement becomes part of a carefully practiced routine. At first glance, these procedures might seem slow, Yet they are simply another expression of an important philosophy that quietly appears again and again throughout the history of exploration. Preparation is often what makes adventure possible. There is another principle that future Martian engineers are almost certain to follow. Never depend on only one solution. Imagine living in a remote mountain cabin during winter. If your only source of heat suddenly failed, the situation could become dangerous very quickly. Most people would feel much more comfortable knowing there was another fireplace, another heater, or at least another way to stay warm. The same thinking guides the design of a Martian settlement. If one air system stops working, another should immediately take over. If one power source becomes unavailable, another should already be waiting. If one section of the habitat is damaged, the remaining sections should continue protecting the people inside. The colony is designed not around the hope that nothing will ever go wrong, but around the expectation that, sooner or later, something probably will. Perhaps the most interesting feature of the first Martian settlement is that it is unlikely to resemble a city at all. There will probably be no towering skyline rising above the horizon, no wide streets filled with thousands of people. Instead, the colony may begin with only a handful of connected habitats, then another and another, each new building making life a little easier than before. Like a small village slowly growing beside a quiet river, the settlement expands one careful step at a time, each generation leaving behind a stronger foundation for the next. And once those walls are standing, warm against the cold and steady against the wind, another challenge quietly takes center stage. A shelter alone cannot sustain life. Even the strongest home must still breathe, drink, and produce the energy that keeps every light glowing through the long Martian nights. A shelter can keep the cold outside. It can protect people from dust, soften the effects of radiation, and provide a place to sleep after a long day's work. But even the safest shelter is only an empty shell if it cannot support life. Imagine spending a winter night inside a beautiful mountain cabin. The walls are strong, the roof keeps out the snow, the windows are tightly sealed against the wind. Yet if there is no heat, no clean water, and nothing to eat, the cabin quickly becomes little more than a carefully built box. A settlement on Mars faces exactly the same reality. The buildings themselves are only the beginning. What truly matters is everything quietly happening inside them. The gentle circulation of fresh air, the steady flow of clean water, the soft glow of lights, the quiet hum of machines that almost disappear into the background because they never stop working. Perhaps no resource is more important than electricity. Here on Earth, losing power is usually an inconvenience. The lights go out, the refrigerator grows warm. Perhaps the internet disappears for a little while, encouraging an unexpected evening by candlelight. Most of us assume the electricity will eventually return. On Mars, the situation would feel entirely different. Electricity is not simply about comfort, it is life itself. Without power, the heaters stop working. The air can no longer be cleaned and circulated. Water cannot be purified. Communication systems fall silent. Scientific instruments shut down. The lights keeping plants alive begin to fade. One by one, every system supporting human life begins to slow. That is why future Martian settlers are unlikely to think of electricity as a luxury. They will think of it the same way sailors once thought about the hull of their ship. Everything depends upon it. So where will that electricity come from? One obvious answer is the sun. Although Mars is farther away from the sun than Earth, sunlight still reaches its surface every day. Large fields of solar panels could quietly collect that energy, transforming light into the electricity needed to keep the colony alive. It is a beautifully elegant idea. Every sunrise becomes another delivery of energy. No fuel truck arrives. Nothing needs to be mined first. The sunlight simply arrives, just as it always has. Yet Mars rarely offers simple solutions. Dust slowly settles across solar panels, reducing the amount of sunlight they can collect. Sometimes the planet experiences enormous dust storms that spread across regions larger than many countries on Earth. During those periods, sunlight may become much weaker for days or even weeks. It is rather like trying to charge a battery while thick clouds refuse to leave the sky. The energy still arrives, just much more slowly. Because of this, many scientists believe future settlements will probably combine several different sources of electricity rather than relying upon only one. Some of the most promising ideas involve small nuclear reactors designed to operate safely for many years. Unlike the enormous power stations familiar on Earth, these compact systems would quietly provide reliable electricity regardless of weather, daylight, or the changing seasons. In many ways, they resemble a dependable fireplace that continues burning through the longest winter, even when snow hides the landscape outside. Perhaps the most sensible solution is balance. Solar energy when sunlight is plentiful, stored energy for emergencies, reliable reactors working steadily in the background, different systems supporting one another, just as different members of a crew support one another. That same philosophy appears again when we think about breathing. Every breath you take on Earth feels effortless. You never stop to wonder where the next breath will come from. The atmosphere has already prepared it for you. Mars has not. Outside the habitat, the air is dominated by carbon dioxide, the gas that plants quietly remove from Earth's atmosphere every day. Human beings, however, cannot breathe it. Future settlers must therefore create their own oxygen. Fortunately, the Martian atmosphere provides an unexpected opportunity. Although it cannot support human breathing directly, it still contains the raw material needed to produce oxygen. Engineers have already demonstrated that it is possible to separate oxygen from the surrounding air using specially designed equipment. It is a remarkable achievement, not because the machine itself is especially large, but because it proves an important idea. Mars already possesses some of the ingredients needed for human survival. We simply have to learn how to use them. Water follows a similar story. At first glance, Mars appears completely dry. Its rivers vanished billions of years ago. Its lakes disappeared. Its oceans, if they truly existed, are long gone. Yet beneath the dusty surface, enormous quantities of water remain hidden in the form of ice. In some places, spacecraft have even photographed brilliant white ice, exposed where the ground has been disturbed. Imagine arriving at an old farmhouse during winter. The fields seem empty. The ponds appear frozen. Nothing seems to move. Yet beneath the ice, water patiently waits for spring. Mars asks us to think in much the same way. Its water has not entirely disappeared. It has simply changed where it lives. Finding that ice is only the first step. The water must then be collected, melted, cleaned, stored, and carefully protected from being wasted. Every drop becomes part of a continuous cycle. Water is used, recovered, purified, used again. The colony gradually learns to treat water almost the way nature treats it on Earth. Not as something to consume once, but as something that endlessly travels in circles. This idea of recycling extends far beyond water. Air is continuously renewed. Waste materials become useful resources. Even warmth produced by one machine may help heat another part of the habitat. Nothing valuable is casually discarded. The entire settlement begins behaving less like a collection of separate machines and more like a living organism. Inside your own body, billions of cells quietly cooperate without asking for attention. Your lungs provide oxygen. Your heart carries it. Your kidneys filter waste. Each organ performs its own task while supporting every other. A Martian settlement must eventually learn to function in much the same way. No system truly stands alone. Electricity powers the machines that clean the air. Clean air allows people to remain healthy. Healthy people maintain the machines. The machines help produce clean water. Clean water supports both people and plants. Plants contribute food, while also helping maintain the atmosphere inside the habitat. One small interruption can ripple through the entire colony. Imagine removing a single gear from a finely crafted mechanical clock. The missing piece may seem insignificant by itself, yet before long, every hand on the clock stops moving. A Martian settlement works in much the same way. Its greatest strength comes not from any individual machine, but from the quiet cooperation between all of them. There is one more remarkable task these systems may eventually accomplish: helping people return home. The same resources used to produce oxygen and clean water may also provide the ingredients needed to manufacture rocket fuel on Mars itself. Rather than carrying every drop of fuel across millions of kilometers from Earth, future explorers may create part of it after they arrive. It is an elegant idea. The planet that once seemed to offer almost nothing gradually begins supplying exactly what explorers need to continue their journey. Little by little, Mars changes from an empty destination into an active partner in human exploration. Not because the planet itself has changed, but because our understanding of it has. And as these invisible systems quietly learn to breathe, recycle, and sustain life together, another challenge begins to emerge. Keeping people alive is only part of the story. Helping them truly live means providing something just as essential: a reliable source of food, and the knowledge to care for one another when illness or injury inevitably arrives. By now, our imagined settlement on Mars has begun to resemble something more than a collection of machines. Its lights remain on through the long nights. Its air is carefully renewed with every passing hour. Its water flows in quiet circles, never wandering very far before beginning another journey through pipes, filters, and storage tanks. From a distance, the colony almost seems alive. Yet there is one question that still lingers quietly in the background. What will its people eat? On Earth, food feels wonderfully ordinary. A loaf of bread appears on a supermarket shelf. Fresh vegetables arrive every morning. Fruit grows in orchards. Wheat waves across enormous fields, and fishing boats return to harbour carrying the day's catch. Even when we pause to appreciate a good meal, it is easy to forget how enormous the living network behind that meal truly is. Sunlight nourishes plants. Rain waters the soil. Countless tiny organisms enrich the ground beneath our feet. Insects help flowers become fruit. Farmers care for the crops. Thousands of people work together so that dinner quietly appears on our tables. Mars begins with none of these gifts. There are no forests waiting to be harvested, no rivers supporting fish, no rich farmland stretching toward the horizon. Even the soil itself presents an unexpected challenge. At first glance, Martian soil appears almost inviting. Its reddish color gives the impression of an enormous desert, perhaps not so different from some of Earth's driest regions. One might imagine planting a seed, adding a little water, and patiently waiting for green leaves to appear. Reality is much less accommodating. The loose material covering Mars has never been shaped by billions of years of living organisms. Here on Earth, healthy soil is far more than crushed rock. It is a busy community. Tiny bacteria quietly break down organic matter. Fungi weave delicate networks beneath the surface. Earthworms gently mix the soil. Countless microscopic creatures help release nutrients that plants need to grow. A handful of Earth soil contains an astonishing amount of hidden life. Martian soil tells a very different story. It is dry, dusty, mineral-rich in some ways, yet lacking the living ecosystem that makes agriculture possible on Earth. It is rather like comparing a freshly baked loaf of bread with a bowl of flour. Both contain some of the same ingredients. But only one has already gone through the long process that transforms simple materials into something ready to nourish life. Because of this, the first gardens on Mars are unlikely to resemble traditional farms at all. Instead, they may look more like carefully controlled indoor laboratories. Imagine walking into a quiet greenhouse. Outside, the landscape remains cold, dry, and silent. Inside, however, rows of green lettuce gently sway beneath soft white lights. Tomato vines slowly climb upward. Herbs release faint fragrances into the carefully filtered air. Small strawberries ripen one by one, bringing unexpected splashes of color into an otherwise reddish world. The contrast would be extraordinary. Just beyond the walls lies one of the harshest environments in the solar system. Inside grows a tiny piece of spring. Many of these plants may never touch natural soil at all. Instead, their roots rest inside carefully prepared streams of water, carrying exactly the nutrients they need. If you have ever placed fresh flowers into a vase, you already understand the basic idea. The flowers continue drinking water even though they are no longer growing in the ground. Future Martian crops simply take that idea much further. Some systems may even allow roots to hang gently in the air, while a fine mist provides both water and nutrients. Rather than sitting in soil, the plants are surrounded by tiny droplets that quietly deliver everything required for healthy growth. These techniques may sound futuristic, yet their purpose is wonderfully simple. Provide plants with precisely what they need while wasting as little water as possible. Every leaf becomes valuable. Every seed matters. Every successful harvest strengthens the colony's future. Over time, these indoor gardens may begin serving another purpose beyond food. Imagine spending months surrounded by metal walls, computers, pipes, and machinery. Then imagine opening a door and stepping into a room filled with green leaves gently moving beneath warm lights. The air feels slightly different. There is a faint scent of growing plants. Tiny drops of water shimmer across fresh vegetables. For a brief moment, the habitat no longer feels entirely artificial. It feels alive. Scientists who study long-duration missions often suggest that gardens could become surprisingly important for emotional well-being. Plants remind people of home. They change with the seasons, even if those seasons are created by carefully programmed lighting instead of nature. Watching something grow offers a quiet reassurance that life continues moving forward, even on a world where almost nothing grows naturally. As the colony becomes more established, another important realization begins to emerge. Plants cannot thrive alone. Just as people depend upon plants, plants also depend upon an entire network of invisible helpers. Tiny microorganisms may eventually become some of the colony's most valuable residents. Although invisible to the naked eye, they quietly recycle waste materials, release nutrients, and help maintain the balance needed for healthy food production. Once again, Mars gently teaches the same lesson. Nothing truly survives alone. The colony slowly begins resembling a miniature living world. Water moves in circles, air moves in circles, nutrients move in circles. Even materials that seem like waste today may become tomorrow's valuable resources. Nature has always worked this way. Humanity is simply learning how to recreate a very small version of Earth's remarkable balance. Of course, no matter how carefully people prepare, illness and injury can never be eliminated completely. Someone may develop an infection. A scientist may slip while working outside. A mechanic may accidentally injure a hand while repairing equipment. On Earth, such situations usually end with a visit to the nearest hospital. Mars quietly removes that option. There is no ambulance waiting just beyond the habitat, no nearby specialists, no operating room only a few minutes away. The nearest fully equipped hospital remains millions of kilometers from the patient. That reality changes how future astronauts must prepare. They will almost certainly become far more than explorers. Each member of the crew may learn at least the fundamentals of emergency medicine. Engineers may receive medical training. Scientists may practice caring for injuries. Doctors, in turn, may learn how to repair equipment or operate essential machinery. On Mars, professional boundaries become softer. Everyone contributes wherever they are needed. Imagine living in a small village many centuries ago, where every neighbor possessed several practical skills. One person might build houses while also caring for livestock. Another might grow food while understanding basic medicine. Communities survived because knowledge was shared rather than divided too narrowly. The first Martian settlement may feel surprisingly similar. Versatility becomes just as valuable as expertise. There is another reason this flexibility matters. Small problems rarely remain small for very long. A damaged water pump can affect food production. A failed air filter may reduce the quality of the habitat's atmosphere. A shortage of medicine may influence the entire crew's ability to continue working. Like the gears inside a beautifully crafted clock, every part of the settlement quietly depends upon every other. Yet perhaps there is something comforting hidden within that complexity. Each challenge solved makes the colony stronger. Each successful harvest teaches valuable lessons. Each repaired machine adds experience that cannot be learned inside laboratories on Earth. Little by little, Mars ceases to be merely a place where people survive. It begins, in its own quiet way, to become a place where life slowly learns how to flourish again. And as those first gardens continue growing beneath gentle lights, another question naturally begins to take shape. If a handful of people can build a thriving settlement together, could that settlement someday become something even greater? A true society with its own future, its own identity, and perhaps one day, its own civilization. As our quiet journey across Mars gradually draws toward its final reflections, it is worth pausing for a moment to look back at how much has already changed. We began with a silent, frozen world where rivers had long since vanished beneath layers of dust. Then, little by little, people arrived, not in great numbers, but as a handful of explorers carrying knowledge instead of certainty. They learned how to build shelters, how to recycle every precious drop of water, how to grow food beneath gentle lights, how to protect themselves from radiation, dust, and the long loneliness of another planet. Eventually, a remarkable transformation begins to take place. The settlement no longer feels like a temporary expedition. It begins to resemble a community. And that raises perhaps the most fascinating question of all. When does a base become a colony? The difference may seem subtle at first, but it is profound. A research station exists because another place supports it. Food arrives from elsewhere. Replacement equipment arrives from elsewhere. New people arrive from elsewhere. If those deliveries stopped completely, the station would eventually stop functioning. A true colony is different. It slowly learns to stand on its own. Imagine planting a young tree in your garden. During its first years, it depends heavily on your care. You water it during dry weather. You protect it from strong winds. You support its fragile trunk with wooden stakes. But after many years, something changes. Its roots spread deep into the ground. Its branches become stronger. One day, the supports are quietly removed because they are no longer needed. The tree has become independent. A Martian colony faces a similar journey. The first settlements will almost certainly rely heavily on Earth. Food shipments, medical supplies, replacement electronics, scientific instruments. Even simple tools may travel across millions of kilometers before finally reaching the colony. But no civilization can depend upon distant deliveries forever. Every rocket launched from Earth carries enormous costs. Every shipment requires years of planning. Every delay introduces uncertainty. If Mars is ever to become a permanent home, the settlers must gradually learn to create more of what they need, using the resources already around them. This idea reaches far beyond growing vegetables or producing oxygen. Eventually, the colony may need workshops capable of manufacturing spare parts, machines that repair other machines, factories producing construction materials, laboratories creating medicines. Perhaps one day, even computers built using materials found on Mars itself. At first, that sounds almost impossible. Then again, many ordinary things in modern life would have sounded impossible only a few centuries ago. A person from the Middle Ages might struggle to imagine airplanes crossing oceans every day, or tiny devices allowing families on opposite sides of Earth to speak face to face. Human history is filled with ideas that once belonged entirely to imagination before quietly becoming everyday reality. Mars may simply represent another chapter in that long tradition. Of course, technology alone cannot create a civilization. People do. Imagine a child born on Mars many decades after the first settlers arrived. Unlike their parents, this child has never watched rain fall from dark clouds. They have never felt waves rolling gently onto a beach. They have never walked barefoot across warm grass on a summer afternoon. Instead, their earliest memories may include long corridors inside pressurized habitats, carefully tended gardens glowing beneath artificial light, and stories told by grandparents about a distant blue planet they once called home. For them, Mars would not feel like an expedition. It would simply feel like home. That thought quietly changes the conversation. The first astronauts travel to Mars. Their grandchildren may belong to it. How would such a society grow? Every community develops its own traditions over time. Shared experiences become stories. Stories become culture. Culture gradually shapes identity. Perhaps holidays would celebrate the arrival of the first settlers. Perhaps children would learn about Earth in the same way many people today learn about distant historical kingdoms. Important, fascinating, deeply respected, yet wonderfully far away. No one can know exactly how such a civilization might evolve, and perhaps that uncertainty is part of its beauty. There is another dream that often captures people's imagination whenever Mars is discussed. Could we one day transform the entire planet? The idea is sometimes called terraforming, a word that simply means reshaping another world so it becomes more like Earth. It is an astonishing vision. Imagine a thicker atmosphere slowly returning, frozen water melting into rivers, plants gradually spreading across valleys that have remained barren for billions of years. Perhaps, one unimaginably distant day, someone might stand outside without needing a protective suit. It is a beautiful dream, but today it remains exactly that, a dream. Scientists have proposed many fascinating ideas. Some imagine releasing gases that could gradually warm the planet. Others have suggested placing enormous mirrors in space to reflect additional sunlight toward the surface. Still others have wondered whether an artificial magnetic shield might one day help protect a thicker atmosphere from slowly escaping into space once again. These ideas are scientifically interesting. They encourage creative thinking and inspire valuable research. Yet they also remind us how incredibly difficult planetary engineering truly is. Building a habitat is one challenge. Changing an entire planet is something altogether different. Perhaps the greatest lesson Mars teaches is not about changing other worlds. It is about understanding our own. Throughout this journey, we have quietly discovered how many invisible gifts Earth provides every moment. A breathable atmosphere, flowing water, protective magnetic fields, rich living soil, an astonishing diversity of plants, animals, and microorganisms working together in delicate balance. These are not ordinary conveniences, they are extraordinary achievements of nature, developed over billions of years. Sometimes we only recognize the value of something after imagining life without it. Mars allows us to perform exactly that thought experiment. By studying a world that lost so much, we begin to appreciate more deeply the world that still surrounds us every day. Perhaps that is why exploring Mars has never truly been about escaping Earth. It has always been another way of understanding Earth. The farther we look into the universe, the more precious our own planet appears. And perhaps that is the quiet paradox waiting at the end of our journey. Humanity dreams of reaching another world, not because we love Earth less, but because exploring the universe teaches us how remarkable home has always been. So as the soft sunlight fades across the Martian horizon, and the first stars begin appearing above that silent landscape, it becomes easier to understand why this lonely world continues calling to us. Not because it promises an easy future, but because it invites us to become wiser explorers, better engineers, more thoughtful caretakers, and perhaps, above all, more grateful inhabitants of the extraordinary blue planet where our own story first began. May that thought stay with you like the final glow of a peaceful sunset, quiet enough to accompany you into restful dreams, carrying with it a gentle sense of wonder for the countless worlds scattered across the universe, and for the rare, beautiful one that has always been waiting beneath your feet. Good night,